Hello everyone, welcome back. We just finished the chapters on ethers, alcohols and epoxides. That has about 7 lectures from videos lecture 25 to lecture 31. It is a more comprehensive discussion on ethers, alcohols and epoxide. Each functional group was discussed, and it has a very detailed discussion on each one of the functional groups of their reaction, how they will be synthesized, and the different kind of chemistries that you would see, especially dehydration, epoxide ring opening, carbocation rearrangement, elimination reaction, competition between SN1, SN2, E1, E2, identifying which functional group would or which condition would result in elimination or in substitution. So I have clearly discussed those in these 7 videos. So I really encourage all of you to review that video, which is valuable for understanding this chapter. But in this video, in the next video, or in this particular video and next subsequent videos, I will be solving all problems that are possible in this chapter. So the next video and subsequent videos will have a detailed step-by-step solution to problems. So we'll start from simpler functional group identification, nomenclature, then slowly we go to how they will be synthesized, and then we'll see also the various rearrangements that can happen, and I also discuss the mechanisms. So it's very important you understand mechanisms and memorizing each one of them. So make sure you understand the lecture portion, which is covering lecture 25 to 31, but following that, starting from today in this video, I will be solving problems in ethers, alcohols, epoxide. This is equivalent to chapter 9 in organic 1 chemistry course. So make sure that you review those. And finally, I would like to thank all of you who sent me questions, feedbacks, very positive suggestions, and also feedback from you. And I love to have more of those feedbacks from you, and thank you. So we'll just continue now the problem solving sessions on alcohols, ethers, and epoxides. Okay, let's begin with a simpler problem. This is an IUPAC naming of alcohols. So you'll see in the board I have 4 problems. To just the problem is to give their IUPAC name. In general, as you see, all of them are alcohol functional group. They have an alcohol. For example, the first one is a primary alcohol. It's only attached to the first carbon. So usually in naming, it's much easier to write them in a stick form than like. So if I redraw this in a stick form, this is equivalent to 2 CH3s, and this is CH right there, and 1 CH2, another CH2, another CH2, OH. So this is equivalent to what you see it on the structure. And it clearly shows you it's a primary alcohol. It's at the tip of the chain. So you always count on a chain that is containing the hydroxy group, the alcohol group, the alcohol functional group. So this is carbon 1, 2, 3, 4, 5. So it's a pentanol. Because it's a 5 carbon, we call it pentanol, an alcohol. So this is not pentane because it's not a straight just carbon-hydrogen bond, but it has an OH functional group. We call that 5-pentanol. So the pentanol has at one position, of course, the OH is there. At 4 position, you have a metal group, because the chain we count was 1, 2, 3, 4, 5. So at 4 position, you have a substituent. So for metal, the name would be 4-metal, 1-pentanol. Don't forget, it's pentanol. So that's how you name an alcohol. Let me redraw also the second question. It has a CH3 and a CH. That one. Another CH2, a CH and CH2, and a CH, which has an ethyl group. And the next CH has an OH group. And I have another CH2 and CH3. So basically this would be reduced, or in a stick form, you would see that alcohol. So what is the naming? You don't start counting from this chain, the longest chain. You rather count from this end, because the alcohol should have the lowest number. If I counted from here, 1, 2, 3, 4, 5, you don't say a 5-hydroxy or a 5 position. So rather you start counting from here, 1, 2, 3. The priority is close to where the alcohol is. So 1, 2, 3 position on alcohol. At 4 position I have ethyl. 5 at 6 position I have metal. So it is 1, 2, 3, 4, 4 ethyl. You start with alphabetically. You start with ethyl, 4 ethyl, 4 ethyl, 5 metal. No, 6 metal. That's 1, 2, 3, 4, 5, 6 metal. And the total number of carbon, 1, 2, 3, 4, 5, 6, 7, heptanol. So at 3 position, 3 heptanol. So that is a 7-carbon alcohol. It's called heptanol, but the alcohol is at 3 position, and at 6 position I have metal, and at 4 position I have ethyl. The reason I bring 4 ethyl, E takes priority than M in alphabetical order. So if you just, the way it was counted was 1, 2, 3, 4, 5, 6, 7. A 7-carbon, which is heptanol. Okay, let me also, I have already this in a stick form, which makes it much easier. So I will take the longest chain. The longest chain that has OH included is this one. 1, 2, 3 position. 4 position, I have another ethyl. 5 position, I have metal. 6, 7, 8. So this is an 8-carbon chain, which makes it an octanol. So at 3 position I have alcohol, at 4 position ethyl, at 5. So I will start by saying 4 ethyl, 5 metal, 3 octanol. 1, 2, 3 octanol. That's how you would name this. In this one, you have a cyclohexane group, and OH takes priority. So OH is at carbon 1, and you don't count this way because this substituent would be at higher number. You don't want to do that. The lowest number is what you should always use. So 3. But if you had counted this way, 1, 2, 3, 4, 5. So you don't say 5 dimethyl. rather you say it at 3,3 dimethyl. So the way this would be named would be 3,3, because there are two dimethyl because there are two of them, dimethyl, one, or you just say cyclohexanol, because it's already known that at one position is your alcohol. So obviously if this is 3 and it is a cyclohexanol, we already knew the alcohol is at one position. So usually we don't write the 1. The 1 is, we know that's where we started, and we know that is the function. So for example, if I just say 4-methyl pentanol, you should understand that the alcohol group is at one position. So even in some cases, they may not write 1 cyclohexanol. You just say 3,3-dimethyl cyclohexanol. I would immediately know if this is 3, 1 the hexanol, the alcohol would be at one position. So that's how you would name alcohols. So we have more problems on this, so I'll continue solving more of those. Continuing our naming problems, the IUPAC naming, you see on the top in this molecule, you see 3 hydroxy groups. So that means it's not just a monoalcohol, it's not a diol, alcohol, it's 3 of them. It's a triol compound. Triol, meaning that there are 3 hydroxy or alcohol groups in this compound. So the straight chain obviously is this chain: 1, 2, 3, 4, 5, 6, 7. So it is a heptanol, heptatriol. So it is a 7 carbon at 2 position. So the alcohols are at 2, 3, 4. So we can call this a 1, 2, 2, 3, 4. So it's 2, 3, 4 are triols. At 5 position I have metal. So it is a 5-metal, 5-metal. It is a 2, 3, 4 heptatriol. The 3 alcohol, triol, not diol. If it was only 2 of them, you can merge them as a diol. If there are 3, they are a triol. So it's a hepta, which is 7 carbon. At 5 position, this is my 5 position. This is my 7 position. This is my 2 position, 3, 4. So that's how I counted them. So this compound is called 5-methyl 2,3,4 heptatriol. In this case, there is a cyclopentane ring, so it will be a cyclopentanol compound as alcohol. But one thing you should remember is this is the stereochemistry is defined. So whenever wedge and also a solid line is given like that, you should also consider including the stereochemistry as well as that position. So the hydrogen, that means here is in. The hydrogen here, it means is up. So in this case, I just did the assignment. So this position is R, and this is also an R. So they would be RR. So this is a 1 position. So it's 1R, comma, 1, 2, 3 position is also R. You should figure out that. That's not part of now the problem, because during the stereochemistry discussion we have already discussed how to name, how to assign R and S. So you should always proceed by their stereochemistry, 1R and 3R, and then start naming regularly. So this is isopropyl unit, because isopropyl, if you're to write this, rewrite that, it will look like this. that is an isopropyl. It is like this. This is isopropyl. This unit is called isopropyl. Always remember that side chain, the substituent, is called isopropyl. So at 3 position I have isopropyl, 3 isopropyl, and at 1 position is alcohol, so 1 cyclopentanol, pentanol. So this is how you name it. Important concept here is we included the stereochemistry also. So at 1 position it is an R, this is 1 position, this is 3 position. Both, as I just did it, it's an R. You can make sure I have the right configuration, but the stereochemistry is included in parentheses always. So we have another one here in this compound. This compound is not a triol, it is a diol now, because there are 2 compounds. At 2 position I have one of the alcohols, at 3 position, so it is a 2,3. At 2 and 3 they are also R, 2R, 3R. That is the stereochemistry of the alcohol, because if you just go, the priority is going like this, that is that's going this way is R, but going this way is also R. So it is a 2R, 3R position, and it's a diol. A 2,3 position, the diols are, and the number of carbon is 1, 2, 3, 4. Carbon number 4 is here, 3, 2, 1. So it is a 4 carbon. It is called butane diol. 2,3 butane diol. Butane diol. So it is a 2R, 3R, indicating that the stereochemistry of the hydroxys are at position, both are RR. So if this wasn't given and you are asked to draw the structure reversely, this is what you draw. A 2R, 3R, meaning that at 2 positions the hydroxy is R configuration. At 3 positions the hydroxy is also an R configuration, and that is the name. So it's very important in naming alcohols where there is a stereochemistry defined, you need to include it in parentheses. R again. So 2R, 3R, 2,3 butane diol. This 2,3 shows us the alcohols, the 2 alcohols are at 2 and 3 positions. The 2R, 3R tells us at 2 and 3 position, the alcohols are oriented or their stereochemistry is RR. So we'll continue solving more problems with this. Okay, here the question is on this compound is to identify them as ethers, epoxides, and alcohols. It's a very simple question, but I will try also to name them. So if you look at here, a cyclohexyl group, another cyclohexyl group is linked through an ether bond. So it is a carbon-oxygen-carbon bond. So obviously this is an ether functional group, ether compound. So if you were to name this, it is a dicyclohexyl ether. So it's dicyclohexyl ether. So it is di because there are 2 of them. This is a symmetrical also. It is a symmetrical ether. Why? Both sides of the oxygen, center is oxygen, they are the same. Such ethers are called symmetrical ether, and it's dicyclo ether. Here we see an ether as well, carbon-oxygen-carbon bond. Carbon-oxygen-carbon bond. This is an ether, But in this case now, the two groups left and right of the oxygen is not symmetric. They are not the same group. So it is unsymmetrical, symmetrical ether. So it is an ether functional group. It is unsymmetrical. If I were to just give a general name, this is ethyl, and this is isobutyl, 1, 2, 3, 4. This is an isobutyl. So remember, this is an isobutyl group. If you have something like this, 1, 2, 3, 4 carbon, that is isobutyl. So remember that naming. So an isobutyl, ethyl, ether. So it is an isobutyl, ethyl, ether. That's how I would name it. Here I have a cyclopentane, and the main functional group is a three-membered with oxygen. You remember now by just reading your lecture notes or lecture, that's an epoxide. So it is a 1,2 epoxy compound. It's an epoxide, but substituted at 2 position also is an ethyl group. So if I were to give a name for this is an epoxide compound, it will be 1,2 epoxy, and at 2 position I have ethyl, 2-ethyl cyclopentane. Remember how you name epoxides. A 1,2. Always this is 1, 2. At 2 position you have a substituent, which is ethyl. So that's how you name epoxide. So this functional group is epoxide. So that is an ether. This is an ether as well. How about here? Here you see also this is carbon, oxygen, another carbon. So this is an ether basically. So this is an ether functional group as an identification. I would to name this, the main chain would be this 1, 2, 3, 4, 5, 6, 7. So it is a heptane, and at 3 and 4 position we have substituent. So this is as a substituent, it is a 3 carbon, 1, 2, 3. If it was 2 of just 2 carbons, it would be etoxy. If it was only one CH3 group there, it would be methoxy. So remember, ethers as a substituent, at least you need to remember names like methoxy for simple metal oxygen. For 2 carbons, it is etoxy. For a 3 carbon substituent, propyloxy. So here I have a propyloxy substituent at 3 position, and at 4 position I have a dimethyl. So this compound is a 4,4 dimethyl, 3 propyloxy, that is the ether oxy, and the chain is 1, 2, 3, 4, 5, 6, 7 heptane. That's how I would name that. It is a 4,4 dimethyl 3 propyloxy heptane. That's correct. So let's continue here. Obviously, as you see here, this is an epoxide. Always epoxies are named as where the oxygen 20 is 2. So you have 1 carbon, 2, 3, 4, 5, 6. So it's a hexa compound. But at 1 and 2, and at 2 position also there is a metal group. So this is called 1,2-epoxy, obviously. That's for sure, 1,2-epoxy. At 2 position you have metal. And the whole chain is hexane. 1,2-epoxy, 2 metal, hexane. Good. Now let's also see here, this is an ether because you have carbon, oxygen, carbon. That's an ether. This is symmetrical ether also. Symmetrical. The same left and right. R groups are the same. So symmetrical ether. Tert-butyl group, by now you should know tert-butyl is this group. So this is a di-tert-butyl, di-tert-butyl, tertiary butyl ether. So it is a di-tertiary butyl ether. So these are simply because we were naming alcohols in the previous section, but mostly now in this section you saw epoxides and also ethers in this discussion. Ethers, epoxides. So we'll move on, solving more. Okay, in this question set, we are asked to give the structure of the name that is shown from A to E. These are different compounds. So we are tasked with identifying the structure. So for the first one, it says decanol. So it's a 10 carbon alcohol. At 4 position, you have the alcohol. So I would start by just always giving the base structure. So 4 decanol is 10 carbons. So I will start by drawing 10 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it is a 10 carbon. And at 4 position, I have the alcohol, decanol. 1, 2, 3, 4. That's 4 position, OH. So that's 4, position 4. And at 7, 7, I have diethyl. So that means 1, 2, 3, 4, 5, 6, 7. Diethyl is this. Those are 2 CH2, CH3, diethyl. And at 6th position, I have sec butyl, secondary butyl. So secondary butyl is this structure. 1, 2, 3, 4. So sec butyl is this substituent. So remember what sec butyl looks like. So that is at 6th position. So 6th position is this right here. So it would be one, two, three, 4. So that is a sec butyl. So that is the structure. 6 sec butyl. This is 6th position. 7, 7 diethyl. 7 is that position. 2 ethyl groups. 4 decanol. 4 decanol. So that's the structure for the first question. Let's do the second one. It says 1,2-epoxy, 1,3,3 trimethylhexane. So the base is a cyclohexane. This is cyclohexane. And it is a 1,2-epoxy, that means an epoxide. So at 1 position, 3, 3. So if this is a one position. Okay, so this is a one position. There would be one metal group at one position, and at three position there would be two of them. One, two, three position, there are two of them. So that's a 1,2 epoxy, one metal, another two metal, because you have trimetal. So that is the structure. In the C, you have 2R, 3S, isopropyl, 2-hexanol. So this is a chain of 6 carbons. At two position, I have alcohol. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So that is X group. 2 position is alcohol. At 2 position, I have alcohol. And at 2 position, the configuration is R. So I will draw the R configuration. So the R would be, if this is up like this, so if this goes down, that should be R. Because if you just go this way, that is an S, but so that is an R configuration. At 3 position, there is isopropyl. So the isopropyl is at 3 position, and it is an S configuration. So isopropyl is this group. But I have to write it an S configuration. So to write the S configuration, the priority is going like this. So if I just have it as a wedge, I think I would be right to write that. That would be an S. So this is a 3S. This is a 2R configuration. I think that's correct. Okay, that is, if you just turn it up. So this is going that way. That should be an S. Let me make sure that I have the right configuration. So the stereochemistry here, priority number 1 is this one. So we go to counterclockwise. That means that would be an S, but since it is down there, it should be an R. You have this compound, priority is for this compound. This right here is so this is a priority actually. Yeah, this side is a priority. If I go this way, it is an R. So it should be actually a dashed line, because if I go this way, that's clockwise, which would give me R, but since it is an S, that is the 3S. So that would be the configuration, 2R, 3S. So 2R, 3S as 3 position isopropyl, 2-hexanol. So that is important. So remember, you should always give the stereochemistry first, and then actually we should also we should have the isopropyl 2, that's 2. So ones which is the ones which are in the parentheses are only showing the stereochemistry of the substituents at that position. Okay. Now let's toxy 3-ethyl heptane. Okay. Now first, this is a 7-carbon compound. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So at one position, what I have is epoxy. So this is a one position, if we call it from here, OCH2, CH3, epoxy. And at three position, I have ethyl. So if this is 1, 2, 3 position is ethyl. Okay. Okay, the last one here is 3-chloro, 1,2-propanediol. So propanediol tells me that it is a propane carbon, 1, 2, 3 carbon, and 1, 2 position are the alcohols. There are 2 of them. If this is OH, one position is also OH. So 1, 2 propanediol, 1, 2 carbon. And at 3 position, I have chloro. 1, 2, 3 position, I have a chloro compound. So that is the structure for the 3-chloro, 1,2-propanediol. So you need to practice more on how to convert name to structure, structure to name. Importantly, the stereochemistry. Don't forget our chapter on stereochemistry. We'll review how to assign R and S as well. Okay, here in this question, it's just asking you to show constitutional isomers of a C5H12O compound when it is an alcohol. So it's always specified here, C5H12O, and it is an alcohol functional group. So that it's asking you to just outline all isomeric different connection of the OH at different places. So the C5H12O would have about 8 constitutional isomers where the hydroxy could be branched and placed in different places. So the way your exercise is you start from a normal chain, 1 pentanol at one position, 2 pentanol, 3 pentanol, and so on. So the main important thing is a C5H12O compound doesn't have any unsaturation, meaning that it's not a ring system with this formula. It doesn't also have double bond. So no unsaturation. This is a saturated system. So in the ring plus double bond or unsaturation, degree of unsaturation calculation, this would become no ring, no unsaturation, no double bond. C5H12O compound is no ring, no double bond. Saturated system, one criteria. Another is you've been told it is an alcohol. So the OH group would be somewhere with all possible combination of constitutional isomers. If you remember, a constitutional isomer is an isomer where you have the same molecular formula but different way of connection. So 1 pentanol is different from 2 pentanol. In 2 pentanol, the hydroxy is on carbon number 2. In 1 pentanol, the hydroxy is on the first carbon. 3 pentanol, as you see, it is 1, 2, 3. It is OH is at 3 position. Then we start branching it. Different way of branching it. For example, 2-methyl 2-butanol is also C5H12O. So it's 1, 2, 3, 4, 5 carbon, 12 hydrogens, and 1 oxygen. But it's named, it's a different molecule, it's a different compound, an alcohol. All of these are alcohols because you're required to give constitutional isomers, which are alcohols. Because with this constitutional isomer, you could have different other things like ethers or alcohols. So, but it is specified that you need to have an alcohol. For example, this one is 3-methyl 2-butanol because this is 1 position, 2 position is the alcohol, and 3 position is methyl. And is here a 2-methyl 2-butanol, two position. For example, this is, if this is carbon number 1, carbon number 2, carbon number 3, carbon number 4. So that is at 2 position I have a butanol, at 2 position I have metal. So this is carbon number 2. Here I have carbon number 2, and here I have carbon number 3. So it is 3 metal, 2 butanol, because the straight chain is 1, 2, 3, 4 carbon. And here I have 3 metal, 1 butanol. 3 metal, 1 butanol. So this is carbon number 1, number 2. At number 3 I have 1 metal substituent. So if I were to draw the stick form of this, it will look like here, the metal group, one of them is here, CH is here already, CH2 is here, another CH2, OH. So it is 1, 2, 3, 4 carbon. At 1, 2, 3 position I have metal group. This is one group. Okay? And the last one is a 2,2 dimethyl propanol, 1 propanol. So propanol, because you have 1, 2, 3 carbon, but these are the 2 metals as a substituents at 2 position. So this is carbon number 2. This is carbon number 1. So that's what it shows, 2,2 dimethyl, 1 propanol. So you need to practice this more. If you are given a formula like that, you should be outlining all possible constitutional isomers. So this is one way of practicing the naming, as well also drawing correct structural formula for a given functional group. Here the functional group is alcohol. You could be asked that all constitutional isomer, including ethers, that means it would increase a lot of structures to draw. But this is specifically only alcohols. So I would ask you to draw all constitutional ether isomers for C5H12O. For example, I can start with showing you just one. If I have 1, 2, 3, 4 carbons here, no, 3 carbons, and the other one is 2 carbon, that's 1, 2 carbon, 3, 4, 5, C5, H12, obviously, 3, 5, 7, 9, 12. So this is C5H12O. I can also write another one CH3 here, and 4 carbons, 1, 2, 3, 4. This is also C5H12O. So you could continue drawing all ethers that are not cyclic but just straight chain ones, and you can come up with several structures. So I ask you to complete all constitutional isomers of ether. So the one we have done here is for if it was an alcohol, but if it is the same formula but it's different functional group, if it was an ether, would look like those. So we'll continue more on your assignment. Okay, so we'll continue more with solving problems in this chapter. So over and over, we'll be going more in detail now to alcohols, ethers, epoxides, their reaction, dehydration, elimination, and so on. So the problems session will continue